And we're back with the developers of Nova, Michael Bosik and Alex Hunt. This is
And Nina's joining us too.
and Nina. I'm sorry. I'm just reading the little names down in the windows. Hi, Nina. Um, so I'm gonna get out of the way and let you all talk.
Ziba,
Hello.
yes, Ziba goes first
Oh,
this time.
hi. It's lovely to be here with you. Could you give us and the audience a quick pitch of what Nova is, please?
Yeah,
You can
go
go,
ahead,
Mike.
Nina.
Um, so our game is a rhythm shooter game with a like retro neon theme to it, like with kind of electronic music. And so you're in space and you shoot asteroids to the beat of the music.
So for this particular title, I think there was a network component. Yeah, can you talk about that?
Yeah,
Yeah, I
so
can
our
talk about that. So our project was done in collaboration with Google Stadia to, to do some research into how you can compensate for latency in games on a cloud gaming platform. So Nova features in-game latency compensation to kind of, uh, sorry, I'm just forming my thoughts here, to like figure out a way to keep the players like quality of experience more or less constant even during periods of high latency.
You say it was a collaboration with Google Stadia. Do you actually use Google Stadia tech, and do you have a contact there? Or?
Yeah, we do. Due to confidentiality reasons, I can't really elaborate on that, but we did
Sure.
work alongside them, and we deployed our game to their platform and tested it with our latency compensation in like a user study with like 27 participants just about.
So we were using their tools to get the current latency between like the client and server. Um, and so then adjusting kind of like the difficulty of the game, it's called like attribute scaling. So the higher the latency, then we want to make it slightly easier for the player so that they have a higher quality of experience. And we ran like user studies with our compensation technique.
Okay, so I mean, between tech and design, there are a lot of potential areas where you could have had, I mean, a lot to chew on. Can you what was the toughest thing of this project, and how did you address it?
um toughest thing, uh definitely like figuring out how to, so the way the music, the targets are created, we analyze the audio in a sound wave, and so we use a plugin called synesthesia in Unreal Engine to do that. And I think that was the most difficult to figure out, partly because there was little to no documentation on how to use the plugin, but also just sound analysis. We had to learn about like what frequencies to look for, and we implemented our solution was to implement a threshold of loudness, so that when the beat of a song, like a hi-hat would go above this loudness threshold, we would uh, create a target at that timestamp within the song.
And if I can follow up with a question, a technical question, uh, how do you prevent the game from finding false positives in that approach?
We came into that problem and we created a cooldown, which basically we can set to any amount of time, so that if there's a, a piece of the song that's above our threshold for longer than just like one uh, millisecond or something, the cooldown goes for a certain amount of time, and all of the peaks within that time are ignored. So we then have just one target each time the cooldown finishes, and we can adjust these values with different songs, um, to kind of like adjust to the different sound waves that were given.
Cool. It sounds like a big part of the thesis of what you're tackling here. The problem is to make sure that a player feels like they're getting a response at the right moment, even if there are network problems. Do you feel like you learned anything about the tolerances that people have? That you found that the technology was working in a range that you wanted it to? Did you get anything there?
Well, I mean, we found with our compensation technique that like we mainly looked at accuracy and like people's, so we were scaling the amount of time that people have to like shoot at each target. Um, and we found that if we increase that based on latency, then there was a higher accuracy and a slightly higher quality of experience. So like we were finding that like our compensation technique was like pretty kind of like, I don't know, showed promising results and could be further experimented with. But I think it's like different games require like different compensation techniques. So this is kind of very specific to our game. And I think the next step would be like looking at other games and it's like, how could this work be applied to like other types of games?
Yeah,
So,
one project that does that, sorry, just our sister project
Please.
Catalyst, who has an interview going on later, also talks about a different method of that. So if you're interested in other different methods of latency compensation, maybe check out their interview.
Great. So, a question apropos what you're just saying. How do you balance the window, the width of the window to basically the width of the window, right? Because if the window for response is too high, then the players can be like, oh, this is really not a challenge. But if it's too low, then that's also a problem.
Yeah, we had another project working with us or alongside us. It was an IQP project that kind of worked to determine how we can do this, and they came up with an equation that we can use to balance the window, and that's what we used in our project. So they did a lot of research on how to do that, and
yeah, so that was taking our game and having different difficulties and then different levels of that like scale, and then like kind of like seeing that there was a decrease and then calculating like how to like change that scale to like have a straight line, if that makes sense.
I think we're near the end here. What is it that's going to stick with you from this project? What are you going to take away from it?
I'm interested in making another rhythm game. Just the concept of rhythm games has like I've started playing like Beat Saber and like Guitar Hero again, and I'd like to make another rhythm game of sorts.
You've got to check out Audica Harmonix' game. It really
Audica too, yeah.
in your zone.
Yeah.
Yeah. Let's see. What do we have more? My goodness, we have 30 seconds left.
No.
What's up next for y'all?
Next year, I'm starting a job at MITRE. I'm going to be doing some user experience engineering.
And I'm applying to jobs as a technical artist and doing some work with a professor over the summer.
Yeah, I'm just doing like freelance QA testing and just trying to find a job as a game programmer. So
good
Perfect.
stuff.
Yeah.
Okay.
Well, thank you all.
Hi, everybody. The voice in your head is back. Thanks, Dyadic, or thanks, Nova. Sorry. You guys are great. Ichiro and Ziba, am I correct? Now you're done?
Yeah, we're done.
Okay.
We're never going to be on camera again.
You could try.
Stop by, keep watching, get in the chat, harass me. That's the way it works. So we're going to switch over. Thank you again. Thanks, everybody.
Thanks for having us.
Excellent. We're going to switch for a brief intermission while we shuffle people in and out.